right, let's get started. Just want to tell you the final is coming up in about 4 weeks. Our final, as I announced at the beginning of the semester, is on Thursday, December 12th. And just like the midterm, there'll be a variety of times to take it. So the lecture section, 1410-001, will either be in here or next door, depending on your last name. So in here are students with last names from A to O. Next door, students from P to Z, and that's 3:30 to 5:30 p.m. Students in the hybrid section, 6 to 8 p.m. in here. The ground rules are pretty much the same. The exam will cover the entire semester. All the lectures, labs, iBooks, problem sets. You need to bring your ID to the exam. You can bring 2 sheets of notes this time to fill out, look at. And I'll be posting some old finals that we'll discuss the last week of the semester. Yes?
If you have old notes, can you use them?
Yeah, you can reuse your old notes. Yeah. Any other questions about that anyway? Okay, we're getting down to the home stretch now. The final assignment came out at the end of last week, and there are a series of due dates for it. The first due date for it is Wednesday. So by Wednesday, you need to take a survey online and let us know whether you're going to work alone or with a partner. And if you're going to work with a partner, you need to tell us who that is. And everyone needs to do that, whether you're working with a partner or not. That's worth 5 points. You get 5 points just for filling out the survey. So be sure to do that by midnight on Wednesday, 11:59 p.m. on Wednesday. The next deadline is a week from Wednesday, so that's the day before Thanksgiving. By then, you need to meet with a TA for 10 minutes, you and your partner if you have one, and demonstrate progress on PS 11. And if you read PS 11B, it talks about what progress means. But there's you're implementing the game of asteroids, as you know, and there's some aspects that you need to have implemented by then. So there's nothing to submit, but you need to meet with the TA and demonstrate it. We're going to be setting up appointment slots starting Thursday. So Thursday through Wednesday, you'll be able to make appointments during those times. Okay? Also, a week from Wednesday, there's another deadline. That's PS 11C, and that's essentially a survey asking how things are going. So everybody needs to do that, and that's 5 points. So 2 things a week from Wednesday. Then the whole thing is due the last Thursday of the semester. You can hand it in Friday if one of you or your partner has a late day. And also, at the same time is due a final progress report, a final progress survey. How do things go? The surveys are really simple. They're 5 points, so you might as well do them. Okay? So that's the schedule. One thing to notice is that there's an extra credit option on the asteroids game. That's explained in the PS 11 handout. But if you want to ask us for extra credit, in addition to submitting your PS 11 in the usual way, you'll have to submit basically a PDF file. You look at the details for EC, for extra credit, EC 11, and you'll see what you need to submit to tell us what you did for extra credit. Okay, does that make sense? Okay, in the labs tomorrow, the TAs are going to help you go through the asteroids, the starting point that I gave you for PS 11, sort of a really broken asteroids game, and let you start experimenting with adding things to it. And then in lecture on 2 days from now, I'll do my own bit of going through, trying to introduce you to how the existing game works and how various extensions can be made. So that's all important stuff. Finally, there will be no lecture the Wednesday before Thanksgiving. Okay, so the deadline for meeting with the TA is 5 p.m. that day. So sort of what would be the lecture time would be your last chance to meet with someone. Okay? Okay. Now, last time, you'll recall, we were playing with, we were working on this simple paint program. And this is the state that we got to. We had the program set up so you could pick a shape like rectangle and a color like green and click, and it would lay down a rectangle of that color centered on the mouse. Or you could pick an oval and do that, or you could pick a line and do that. So the next step we want to do is to make it so that when I'll show you this way, that you can click the mouse and drag it and not just place the oval, but sort of choose its extent. Same thing with the line and the rectangle. As you drag the mouse, you're sort of setting the other endpoint of the line in that case. We're going to do that in 2 steps, and along the way illustrate some more things about inheritance and interfaces and object-oriented programming in Java. So let me just remind you what the code looked like 5 days ago. We were in Paint 5, and that's pretty much copied forward into beginning point for Paint 6 here. Okay, let me see what the right place to start. Okay, you remember that we have an array list of shapes. So at any given time, you've got, if you have 10 shapes in the window there, you'll have 10 shape objects in this array list right here. So that list keeps track of all the shapes that have been placed, so that whenever it comes time to repaint the shapes, you just go through the list and paint them. Now, what is a shape? This type here. What was it? Yeah?
Abstract class.
Was it an abstract class? Good question. I think it was. Yep. It started out life as an interface, and we decided to make it a class. We're going to turn it to an abstract class shortly. So a shape is a class that sort of contains everything that all shapes have in common. So every shape has an XY origin right here, an XY coordinate, which is their origin, and every shape has a color. So every shape object is going to have those 3 instance variables. There's a constructor which just initializes the instance variables. There is a method getX that returns the origin, and a method getY that returns the Y coordinate of the origin. They're both protected. What does that mean? What does it mean for a method to be protected? Yeah?
It's available within the package.
Okay, he said it's available within the package. That would be true if it was like that. If you don't say public, private, protected, it's available within the package. This is different. Yes?
It's available to things that inherit from.
Right, it's available to things that inherit from this class. So when I put getX and getY there and I make them protected, I'm saying I do not intend for these methods to be called from any old place. They can only be called from derived classes derived from shape. Right? Now I also have a paint method which knows how to draw a shape, and it's public, so it's meant to be called from anywhere, but it's kind of curious. All it does is set the color. Okay? So what kind of a method is that? It's supposed to draw a shape, but all it does is set a color. So in what sense does it draw a shape? Yeah?
Is it expected to be overridden? Or?
Okay. He said, is it expected to be overridden? The idea here is that, that's the best you can do. If all you know about a shape is its coordinates and its color, you don't know if it's a rectangle, an oval, a point, anything. You don't know anything about it. It's hard to draw anything, but you can do one thing, and that's set the color. So that method is intended to be overridden, to do something more useful. So this class is written with the expectation that it will be overridden. It's not particularly useful by itself because it doesn't paint anything. So let's look at how it's overridden. We have the oval method, the oval class rather, that extends shape. So it will inherit the 3 instance variables from shape, plus it adds these 3 instance variables, these 2 instance variables, which represent the radius in the x and y directions. So every oval object will contain those 5 instance variables. Here is where we construct the oval. So we get in the sort of the x radius and the y radius. And I'll take that back. We get the x coordinate and the y coordinate in the color, and we turn around and do this. So what does it mean to call this super thing as the first statement inside of the oval constructor? So just, yeah.
You're calling the constructor from shape?
Okay, we're calling the constructor from shape. We're calling the base class constructor. So when I say super XYC, I'm calling the shape constructor because that's what we're extending. And remember, the shape constructor initializes origin X, origin Y, and color for us. And that's good because we can't, these variables are private, right? We can't access them down here. If we tried to do that ourselves, if we tried to say color gets the value of C, that's not going to fly. We can't touch those instance variables. So we have to use the base class constructor to do the work for us. Then we set the radius. Set radius X to 100 and radius Y to 100. Finally, we have this method here to set the extent. So you can, I guess we didn't have this last time, but I've added it to avoid having to write it in front of you. Set extent, you give it the XY coordinates where the mouse currently is, and it computes the radius from that. So it gets the center and subtracts X from it, and that gives the radius in the X direction, and similarly for the Y direction. And here's the overridden paint method. First thing we do is we call super.paint. So what does that accomplish? Well, the paint method here is what overrides the previous paint method. Yeah. Okay. But what does calling super.paint do? That's sort of an extra thing. Yeah.
Doesn't it do what it did in the shape class?
Right. It calls the overridden method. So when someone calls paint on an oval, first thing that method's going to do is call the overridden paint method from the base class, which is shape, and that's going to set the color. And the good thing too, because we can't access the color. So we ask super.paint to set the color, and then we draw an oval. Okay? Rectangle, same way. It has width and height. The constructor, again, calls the base class constructor and then sets width and height to some values. We have a set extent method, which we'll eventually use. And then we use the paint method, which calls the overridden paint method and then draws the rectangle. Line works the same way. It has the line has endpoint. We use the base class constructor, and here we call the overridden paint and then draw. So this is telling us that painting a line is just like painting a shape, except you draw a line. You don't just set the color of the graphics, you draw a line. So that's where we stand now. Now, just to remind you a few more things, let's go back up to where this is used, which is way up here. Okay, what's going on here? Well, actually, let's go here first. What's going on in this method when someone presses a mouse? Someone presses the left mouse button. What's this method do? Yeah.
Depending on the radio button, it will get the source of where you put it and then choose a specific base.
Okay, so we look at we figure out this method will tell us which radio button was selected. And this will get the action command out. And that is either going to be oval, rect, or line. If it's oval, we create a new oval shape and we store it in a shape variable. Why is it okay to take an oval object, a reference to an oval object, and store it into a shape variable? Why doesn't that cause a type error? Why isn't Eclipse screaming at us for doing something? Yeah.
Because oval is very.
Oval extends shape. Oval is a kind of shape. Now, if I did this, then I guess it's rectangle. Okay? It's perfectly happy to store a rectangle into a rectangle variable, but it can't store an oval into a rectangle variable because an oval is not a kind of rectangle. Rectangles, ovals, and lines are kinds of shapes. But that doesn't mean you can store an oval into a rectangle variable or vice versa. This needs to be shape. So essentially, we go and look at which button was selected. We create the proper shape, and then we store it in the list, and then repaint to get it displayed. So the thing about inheritance, it's more than just being able to extend implementation of another class. It sets up what's called a subtype hierarchy. A oval is a subtype of shape. An oval is a kind of shape. And that has it's important right here, you see. Okay, and finally, we're here in the paint component method. We are painting all the shapes. And you'll see we just iterate through the shape list, and we call the paint method. We don't care whether we're painting an oval, a rectangle, or a line. They're all guaranteed to have paint methods because they all extend shape. So we just call them, and depending on what type of object it is, that determines which paint method gets called. The rectangle's paint method, oval's paint method, or line's paint method. So that's where we stood last time. So that's a lot of stuff I've gone over here. Let me pause and see if I can help you with anything. This isn't something that will blow over anytime soon because the Asteroids game makes heavy use of a type hierarchy. You won't be able to get far in that game without extending classes, implementing interfaces. So it needs to be something that's as comfortable to you as writing loops, implementing methods. Yeah?
I just have a question exactly how super works, because last lecture you mentioned the fact, one of the questions was if it would allow you to use privates, and I thought that was a way to override it and get access to private.
Well, like up there when we call super.paintComponent G, we're calling paint component on the base class of paint panel, which is JPanel. Okay? So right here, we're calling the overridden paint component method from JPanel. Now, that method in JPanel is probably going to be accessing some instance variables that I don't even know what they are, because I've never looked at implementation of paint panel. So in a sense, that's a way of using private instance variables, but I'm using them through a method call, the way we normally do. I cannot directly reference the instance variables of JPanel here. You know, I can't say super.x, assuming x is even a variable for JPanel.
So it gives you access to the private instance variables, but in an abstract way.
Right. You could say that. It gives you an abstract way to get at the instance variables. You can call a method that manipulates instance variables. But that's just our typical way of interacting with a class. When you're outside the class, you can't access directly the instance variables. All you can do is call methods, and they'll do it for you. Any other questions? Okay, well, as we go along, you're welcome to ask other questions. So what we want to add to this, let me remind you, is I want to be able to, when I run the thing, I guess it's this. rather than have the oval appear when I click, I want to be able to click, drag, and release, and draw an oval that way. So what am I going to need to change about Paint Panel here in order to have that happen? Yeah?
Some kind of like mouse location listener.
Okay, so there's got to be some kind of, to detect that the mouse was clicked, we had to use a mouse listener. And mouse listener provides you with a set of methods. There's another interface called mouse motion listener. And we need to implement mouse motion listener in order to find out about dragging. So let's go see what we have now. Okay, we have mouse clicked, mouse entered, mouse exited, mouse released. Okay, none of those are what we want. So I'm going to add up here. We're going to implement just not mouse listener, but mouse motion listener. And of course, it's going to tell us, okay, you claim to implement mouse motion listener, but you didn't implement any of the methods that are described by it. So I'll add them in here, and we'll go see what we have now. Okay. So what got added is mouse dragged and mouse moved. Okay, and I think mouse moved is what we want. Let's try it out though. So just to make sure this is working, actually, I don't think that's what we want. I think that'll tell us if the mouse moves regardless of whether the button is pressed. I want to know, did it move while the button was pressed, and that's a drag. So we'll do that. I'll make the console a little bit bigger so you can see what's going on down here. We'll run the program, and then I will press and then move, and nothing's happening, and I remember now why nothing happened. Made the same mistake a week ago. Who could tell me why it's not registering any mouse events here? It's not telling us the mouse is being dragged, yeah?
I didn't add that as a listener thing.
Right, I have to add it as a listener too. So let's go find the right place to do that. Paint panel, there's the constructor. So I don't just add the object as a mouse listener, I add it as a mouse motion listener. Okay, now let's try again. So down it goes, and now you see I'm dragging the mouse and it's telling me it's moved. And when I release the mouse, I just released it, I move the mouse some more and it's not telling me anything. So it only notifies us of the motion when we're dragging with the mouse, with the button pressed down. So back down to here. We have got to figure out each time we move the mouse, each time this event happens, we need to find out where the mouse is at that point. So how are we going to do that? What do you suppose? Yeah?
Like the E has some sort of like get position method or something.
Okay. So yeah, if we look at E here, it has a get X. So it'll give you the X coordinate and the Y coordinate. So I'll print those out so you can see what we're playing with. So let's run it. I depress the mouse, and then as I drag, you can see the X coordinate's getting higher and higher. Now the X coordinate is getting smaller and smaller. Now the Y coordinate's getting bigger. Y coordinate's getting smaller. So that's good. So now we have enough to we have enough information to do what we need to do. Now let's think about what we have to do. Every one of these methods down here has a set extent method. So the idea is when you call set extent, you give it the X and Y coordinates of the mouse. The current X and Y coordinates of the mouse. What it does is it subtracts the center of the oval in this case from the current X mouse position to get a X radius, and similarly for a Y radius. So our job is to call set extent on the shape that we're drawing and just pass it the current x and y coordinate of the mouse. So given that there's one method like that in those three classes down there, what do we need to do here? First of all, what shape? We have a list of shapes. Which one are we currently drawing? Which one are we currently dragging around? Well, it depends. I'm saying, I'm not asking whether it's an oval or rectangle. I mean, there may be 10 shapes on the screen right now. One of them is the one that we're trying to size. How are we going to get our hands on that particular shape?
Could you use this?
Well, this is the panel. I need the actual shape. Yeah.
Is it the last one that's in the array list, the last one that's added?
Right. We have that shapes array list, and we need to get, they get added to the end. Every time we create a new shape, it's added to the end. So we need the one on the end. So let's see what we can do. I wonder if there's a get last. I don't think there is. So I'm going to do shapes.get, and I need to pass in an index, so it's going to be set shapes dot size -1. So that right there is the shape that we're currently drawing. Okay? So we have the shape that we're currently drawing. What do we need to do to that shape? We got the shape, and we got a way to figure out where the mouse is right now. So what method do we call on the shape? Well, let's go back down and look. Here's oval. It has this method setExtent. Here is rectangle. It has a method called setExtent. And here is line. It has a method called setExtent, whose job it is to, to size the thing. So what do we do? What do we do with this current shape up here? I'll get back up to it. Right there. What do we do to current? Yep. Right, we call setExtent. And we pass in e.getX, e.getY. There's a problem. Let's see what it says. It says the method setExtent is undefined for the type shape. Well, what the heck? I just showed you that rectangle has one, oval has one, line has one. Those are the only three kinds of shapes we're using. Where does it get off telling us there's no setExtent method? What's going on? Well, you think about that for a second. You saw with your own eyes those three setExtent methods. Okay? Fill us in.
Sorry. The shape class doesn't have a setExtent, and isn't the array list of type shape?
Right. Our array list that we're working with here is of type shape. And when we pull the thing out of it, we're storing it as a shape. So it's telling us the shape class has no setExtent method. Now, if what we did was we created a shape, if we happen to know it was a rectangle, we could call the rectangle setExtent method, but we don't know that. We don't know what kind of shape we're dealing with. So what do we have to do to fix this problem where rectangle, oval, and line have a setExtent method, but we can't use it because of shape? Yeah.
Add some sort of stubby or completely blank method in the shape class that is setExtent.
Right. I'm going to go down here and copy something. We need to come up here to shape and just add to it a method that sets the extent of this shape. And what should this method do? It can't set radius x and radius y because that just makes sense for ovals. It can't set width and height. That just makes sense for rectangles. What should the setExtent method do?
Origin point?
What's that?
The origin point?
Well, we don't want to change the origin point. That's fixed. Yeah?
I was gonna say set extent one, but that would really work for oval, I think.
Yeah, we don't need to call set extent. Yeah?
Just do nothing.
That's it. Do nothing. This method is intended to be overridden. It's just there so that we can call the set extent method on any shape. Yeah?
Can we just get rid of the brackets and put a semicolon there?
If you just put a semicolon there, no, that wouldn't work. You have to actually implement it. You've actually thought, well, we're going to do something like that next, but it's a little more involved than you're suggesting. Okay? So when we call set extent up here, so now set extent does nothing. When we call it up here, we expect it to do something. And why does it do something when we call set extent up there? We're saying we're taking a shape object and calling set extent on it. Why does it do nothing? Why does it not do nothing when we do that? Yeah?
Because it's being overridden and whatever class it's.
Okay. Yeah, it's overridden. So, this thing here in current is a shape object, but it's also either a rectangle, an oval, or a line. It's both. So if current happens to be a rectangle, then what this means is call the set extent method defined in rectangle. If it's an oval, it means call the set extent method that's defined in the oval. And Java figures it out at runtime, what kind of object that is. And so that stub set extent down there is never going to be called. Unless if we do something like create a shape object directly, as long as we never say new shape in the program, there's no way that thing is ever going to be called. Well, let's see where we stand now. Here we are. I click, and it creates that, but then I drag. Right. Well, that's no good. What's going on here? That isn't a rhetorical question. Well, let's break it down. Why does it show up like that? With a fixed radius? I know the answer to that one. I'll help you out. Let's go down and see. So when we create an oval, we set the radius, the two radii to 100. So I'm going to have them set to 0. And then when we come down here to rectangle, I'm going to set the width and the height to 0. And then when we come down here to line, I'm going to set index to just be the same as x and y. Okay. So now when I click, nothing shows up. I drag, still nothing happens. I let go, nothing appears. So now I'm confused about why nothing's working out here. But there it is. Now I understand. Here, I'm going to click rectangle. I'm going to try to draw one. That didn't work. I'm going to go to blue. I'm going to come over here. Oh, now it shows up. Seem to be one behind things. What do we need to do?
Do we need to move things over to mouse released?
Yeah, we need to tell the panel to repaint itself. So back up here to the mouse drag method. After we have set the extent, we need to say, okay, now repaint so we can see what happened. We don't call repaint, nothing's displayed until something else causes repaint to occur. Okay, now I'm not confused anymore. Let's do this. Here's an oval. That's working. Here's our rectangle. And here's our line. So we're able to paint things now. Yeah?
Why did you set the instance variables to 0?
Okay, he's asking, why did I set, so when I first click, that creates sort of an oval with radius 0. Okay, so why did I set it to radius 0 when I first click? Yeah? Okay?
Well, because until you drag, that oval doesn't have a radius.
Right. So when I first click, I want something of radius 0. It isn't until I start dragging the mouse, well, that's a line. It isn't until I start dragging the mouse that I get something that's not radius 0. So when you first, if all I did was click and let go, I've created an oval, but you can't see it because it has a radius of 0. That's just, so I set to 0 because that's just what I wanted when it's brand new. Now, let's go back and change it. What if I left it the way it was? So back down to oval, and let's set the initial radius to 100 by 50. So what's that going to look like when I run it? When I click and drag, what am I going to see? Yeah?
When you first click, it's going to have a 100 by 50 oval, but then as soon as you drag, it's going to then resize itself.
Right. So the initial click works fine, but then as I start dragging, then it, we start resizing. I don't like the way that looks, right? So that's why I do it that way. Yeah?
What if you define a shape object that doesn't have the set extent method? Because at the moment it's not required because I just removed it and it happened.
Okay. So let's go down here. Oh, there we are. Here's the set extent method in oval. So what would happen if we, I'm just going to call it something else. So there's no set extent method there. What's going to happen when we go try to draw an oval? I will do it now. I'll click. Now, I've still got that. Let me go back to the way I had it. I'm going to click and drag. Okay, what's happening there? We're calling the set extent method, and nothing is happening. How can we call a method that's not there? Yeah?
Is it running off of the shapes set extent?
Right. Since we're not overriding the version of set extent defined in the shape class, we're defaulting to it, and it does nothing. So we just create, all we can do is create an empty oval. Now, what you want to do, when you know you're overriding a method, you want to annotate it with the @ override to say, yeah, I mean to be overriding a method. That way, if you misspell the method, it'll tell you. You claim to be overriding a method, but this method doesn't exist. So it's sort of a fail-safe. Java doesn't require you to say override, and I wish it did, because there were a number of students last week working on their Lights Out games that did something innocuous like create a class that extended JPanel, and then they added a couple methods they wanted. They wanted a getX method and a getY method. And they added that to the class, and then nothing would work. And it puzzled us for a while till I realized that JPanel already has getX and getY methods that it uses when placing the JPanel on the screen. And these students were inadvertently overriding getX and getY with their own methods. And that just completely screwed up the layout. And I can't blame anyone for making that mistake because you don't necessarily know what methods are defined in the class you're inheriting from. But if override were required instead of optional in Java, how would that have helped those students? Or put another way, if override were required, what would happen when I define set extent this way? What do you expect Eclipse would do?
It would say that a method already exists.
Right. It would say, it would tell you, it'd warn you there's already a method called set extent, and you seem to be overriding it without advertising that fact. And so that warning would have been helpful to the students. So this is always a good idea. Okay? Any other questions? Yeah?
Is there a way to set Eclipse to yell at you for that?
Is there a way to set Eclipse to do that? There may well be. If you click on the properties of the project and go to the compiler's properties and drill down, you can customize what warnings you get. And I haven't investigated that, but you might be able to turn on a warning. Anything else? Okay, what do you see as the biggest problem we have right now? The sort of the most awkward thing Now, I'm sort of asking you to read my mind, so just read the projector. I think set extent is a problem. And the reason it's a problem is we want to require people to override set extent. But if they forget, they don't get a warning or anything. So this would be a better design if there was no way for the implementer of a class that extends shape to forget to override set extent. We'd like to force them to override it. So the final change we're going to make to this is to make that possible, make it so that the user is forced to override set extent. So we'll take a break and then we'll look at the 7th and final version of Paint. All right, now I've switched over to the Paint 7 package, which is pretty much identical to what we just created. And I'm going to go back to the problematic method. In the shape class. Set extent. And what I told you is that rather than providing a stub implementation and then hoping that everyone who extends shape realizes they need to override set extent, we can force them to do so. And the way we do that is we get rid of the stub, we put a semicolon at the end instead. So this is just like you'd see in an interface, and we have to mark the method abstract. And I'll explain that error in a second. So when you put an abstract method into a class, you're basically saying this must be overridden. And if someone forgets to override it, they'll see an error message. Now, there's one extra obligation. If you put an abstract method into a class, like I have here, then you have to make the class abstract as well. Okay, so an abstract class is one that contains abstract methods. Now, an abstract class can still have instance variables. It can still have a constructor. It can still have methods that aren't abstract. But it's going to have, typically, at least one abstract method. There is an interesting restriction on abstract classes. You cannot call the constructor directly. So there's that constructor right there, shape, that takes 3 parameters. Let's pass it 4, 5, and color.red. But you look here, it's going to say, cannot instantiate the type shape. And the reason is it's because it's abstract. You cannot do this. You can't say new shape if shape is abstract. So let me ask you this. If you can't call the constructor that way, what's the point of having a constructor? And if you can't call the constructor to initialize the instance variables, what's the point of the instance variables? And if you can't create an object, if you can't call the constructor, how are you going to call these methods? So yeah, what's going on here?
Will the constructor still be used on the classes that inherit it?
Okay, that's the point. You can't say new shape, but you can say super XYZ. So the only time an abstract methods constructor is called is when is from the constructor of a derived class. So in other words, an abstract class is only useful if you extend it. It's a class that's designed to be extended. And if you don't ever extend it, it's useless. So what's the difference between an abstract class and an interface? Abstract interfaces also have the method declarations in them. Not stubs, but method declarations, not implementations. And anyone that implements an interface must, provide implementations for all those method declarations. Same thing with an abstract class. If you extend an abstract class, you have got to provide implementations. You got to override the abstract method. So down here, if I, instead of set extent, if I say set extent X, it's going to complain up here. It's going to say the type oval must implement the inherited abstract method, set extent. Okay? So what's the difference between an interface and an abstract class? Yeah?
Interfaces don't have constructors and
Okay. Interfaces don't have constructors. They don't have instance variables. They don't have other methods they don't have methods that are pre-implemented. They just have a list of methods that you have to implement. So abstract class is kind of like a souped up interface in that it provides some things that are going to be useful to the extending classes, like colors and centers, but it doesn't provide complete functionality. It's intended to be overridden. Now, if you have an interface with a bunch of methods, you could opt to make it an abstract class. You would have an abstract class with no constructor and no implemented methods and no instance variables. In that case, an abstract class is a lot like, that kind of abstract class is a lot like an interface. But if you're going to do that, you might as well make it an interface. It's kind of a simpler thing. And this is all we have to change. Okay? All I did was I declared shape abstract, and everything works as before. It's going to work just like before, but now it's written in such a way that it's clear to anyone that extends the class that the set extent method must be overridden. It communicates that intent. Okay? So that's a fine point. But you'll find abstract classes in the asteroids game. Okay? And I'll talk about that next time. So we've been through this example, and there are sort of lots of code, and I'm trying to make points, some pretty fine points about how inheritance works and how interfaces work and how abstract classes work. But it's easy to get lost with all the code and all the scrolling back and forth with what's going on. So what I want to do next is turn to a simpler set of code and go over the same points again and see if I can hone your intuition. So there's some slides in the module that are worth looking at, especially when you're studying for the final exam. But they cover many of the same things we've already covered and that I'm going to cover here. I want to use code examples. So I'm going to start here, have a demo package, animal.java. So tell me what you know about this class. We have an animal class. Yeah?
All animals need to be able to speak, or have a speak method.
Okay, so it's an abstract class. There are two methods. There's a speak method that's supposed to return a string that is what the string is what the animal says, and it's abstract, which means that this class is intended to be extended, and then when you do extend it, you're going to have to implement the speak method. But notice that shout is implemented, and it operates by calling speak, which is abstract. So how does it work? That I can write code here that calls a method that has no implementation. How's that going to work? Yeah?
Because you're only meant to call it once you extend it into...
Right. We can't call that method until we extend the class and implement the speak method. And at that point, there will be a speak method to call. So before that shout method can be called, someone is going to have to extend the class and provide a speak method. So I have done that. So here's my dog class. Okay? So I have a dog class that extends animal and overrides speak to say woof. All right, let's play around with it. So I'm going to go here and run JShell. And let's try some experiments. So first thing I'm going to say is animal A equals new animal. Okay, predictions. What will happen when I hit enter? What's that? Okay, an error. Why? Yeah, you can't instantiate an abstract class. It says abstract, animal is abstract, cannot be instantiated. Okay, that's because it's abstract. But I can do this. I can say dog D equals new dog. Okay? Now I'm going to say D dot speak. So what's D dot speak going to return? Here's implementation of dog. This isn't a hard question. Woof. I got to put the enter down here. It says woof. What about D dot shout? Is that even legal? I don't see a shout method here in dog. We inherited it from animal. All right, so what's going to happen when I call D dot shout? Here, it's going to just show me woof in uppercase. And the reason that worked is this method, which calls speak and converts it to uppercase, is inherited by dog. And so when it calls the speak method, it's calling the speak method that we just overrode. Now, what if I do cat the same way? Okay, I say cat C equals new cat. What's going to happen when I say C dot speak? It's going to say meow. If I say shout, it's going to give us meow in uppercase because we overrode it a different way for cats. Okay? Now, let's do this. Animal A equals new dog. Is that legal? Can you store a dog object in an animal variable? Okay, why? You can. Here, I've done it. Why is it okay to store an animal, to store a dog in an animal variable? And while we're at it, can I do this? Can I store a dog in a cat variable? No. What's the difference? Go ahead.
You're calling the dog constructor, even though you're storing it as an animal, the dog constructor is still being called.
Well, I'm calling a dog constructor in both places.
But it's overrides.
Okay, yeah. Override isn't the word I wanted to hear. What's the bottom line? Yeah. A dog is a kind of animal. Dog extends animal. So a dog is a kind of animal, and so it's okay. Dog does not extend cat. So you can't do that. Now, there's such a thing as casting. So what if you do this? What if you say, I know that cat's not a dog, so I want you to cast. That's not what I meant to do. I want you to convert this dog object to a cat object for me and store it in a cat variable. What do you think of that? You can't do that. You can't convert a dog into a cat. We all know that. Okay? You can only. Okay. Now, let me show you another thing. So let me straighten this out. Cat C equals new cat. Dog D equals new dog. And let's say animal A equals new, let me do A1. A2 equals new cat. Okay, so there's a cat object stored in the variable C. There's also a cat object stored in the variable A2. Okay? Storing a cat into an animal object doesn't change its fundamental identity. It is still a cat. Okay? But let's find out. Let's ask the question. So there's an operator. This is really the last thing about Java I'm going to teach you. Instance of. You can test objects to find out if they are a kind of. So think of instance of as being synonym for a kind of. Is A2, the object stored in A2, is it a kind of cat? Is it a cat? Is it an instance of cat? Yeah, it was constructed with a cat constructor. It is. Is that thing a dog? No. Okay, what about A1? Is A1 an instance of dog? Yeah, A1 was created with a dog constructor, so it's an instance of dog. Is A1 an instance of animal? Yeah, it is. Is A1 an instance of object? Yeah, everything, every object type, every object's an instance of object. So you can test the type hierarchy. You can find out where something fits in a type hierarchy with instance of. Sometimes that comes in useful. Yeah.
What would you actually use the instance of object for?
Okay, he says, what would you use it for? Okay, let me give you this example. So we've got D here, which is a dog object. And we have A1 here, which is also a dog object, but it's stored in an animal variable. Now, what if I want to do this? Dog X gets A1. So we're taking a dog object that is stored in A1, which is declared to hold animals, and we're trying to store it in that variable X, which is designed to hold dog objects. Is that going to fly? Okay, it seems like it ought to, but it doesn't. And this is the reason why. The Java compiler tries to figure out, before you run the program, it has to convince itself that A1 is compatible with dog. And all the compiler knows is that A1 will contain some kind of animal. It could be a cat, it could be a dog, it could be a snake. And it can't be comfortable storing anything in A1 into X. So, this is called a downcast. When you write the code, you may know that when the code gets to some point, A1 will contain a dog object. And so you do the cast, and then something happens at runtime. At runtime, Java checks to see what does A1 contain. If it's a dog, the cast will succeed. If it's a cat, the cast will fail. So that worked. But A2 contains a cat, and we get an exception there. Yeah?
Is there a way to use instance of to tell if A1 is like a pure animal, that it is not a cat or anything else, it's just animal?
Well, nothing can be just animal because it's an abstract class. Right. But now all you can tell is, instance of just tells you is if you say instance of animal, it's saying is it an animal object, was it constructed directly as an animal object, or something derived from. You can't do the thing that you want to do.
If animal was not an abstract class and we extended it somewhere else?
Yeah, there's no way to test that it's an animal but not an object, for example, with one instance of. Okay? So the question was, what can you do with instance of? What you can do is you could say if A1 instance of dog, you can test to see whether it's safe to do a cast. Then you could say dog x equals, I'll say x. So you can use instance of to test before you do a downcast. You can test to see whether a downcast will succeed. So a downcast is when you have an object stored in a variable like animal, and you want to put it in a more specific context. You want to treat it as a dog or a cat. So let's make this more realistic. Let's add to the dog class a new method called fetch. Okay, so there's our dog class. So let's do this. I'm going to have to reload here. So dog D equals new dog. So now I can say d.fetch, and I get true back. Now I can store it into I'll store it to an animal variable. And now I say a.fetch, and I get an error message. So what's going on? Why can the dog fetch when it's stored in a dog variable? That same object when you store it in an animal variable, you can't fetch. Yeah?
Does it not know if it's a dog object when it's
Okay. He's saying, does it not know it's a dog object? And by it, we mean the Java compiler. So the Java compiler is very conservative. It just sees, okay, there's going to be something stored in that variable A when the statement a.fetch is executed. And maybe it's a cat object stored there, and cats don't have fetch method. And it doesn't try very hard to figure out what might be stored there. In fact, it doesn't try at all. It just asks, can you call fetch on any animal object? Meaning, is there a fetch method defined in the animal class? If there's not, it's not going to compile. But we have inside information. We know that A contains a dog object. So how could we what could we do to that A so we could fetch the dog that it contains? We got to do a downcast. So we do something like this. We say dog A. We cast it to a dog, and then we fetch. That works just fine. Now if we do this, if we say A gets new cat, and then we say a.fetch, the compiler is going to tell us, no, you can't do that. On the other hand, if we do this, try to cast it to dog and then fetch, what we get is an exception at runtime. The compiler said it was okay. It's okay to attempt to do the cast, but when the cast was executed at runtime, the type of A was tested. It was not dog, and so we got this class cast exception. So that causes students problems, is the difference between what happens when you compile, where the compiler is maximally pessimistic. It never assumes that an animal variable contains a dog, even if it's obvious from the code. Compared to what happens at runtime, where if the cast is attempted, if it succeeds, good. If it fails, you get an exception. Now, here is an interface called named. Now, some animals have names. Let's assume all dogs have names. How could we mark? So what would it take to implement this interface over here in the dog class? Or let me make it more concrete. What if I'd like to do this? Will this work? Named N gets new dog. Okay, so we can declare a variable of type name because it's the name of the interface. But if we try to store a dog in it, it'll say, no, I don't know how to convert a dog to a name. They're incompatible. What do I have to do to the dog class so that we can store it in a variable of type named? Yeah? Right, we have to say implements named. And then we got to come to dog here and add the unimplemented method, which is the get name. And we'll return, every dog has a different name, so we'll just say return name. We're going to have a constructor now. And an instance variable. Okay, so now we implement the named interface because there's a getName method. To support it, we had to pass the name of the dog to the constructor and save an instance variable that we return in the getName method. So let's try to reload this. And now let's do this. Dog D equals new dog, and we'll do spot. Now we can say D dot get name. We get spot. Is that going to work? Can we store a dog into a variable called named? I mean, a variable of type named.
No. Yeah.
Okay? I heard two conflicting answers. So whoever said yeah, what's the reason? Right, a dog is a kind of named. So just like extending sets up a subtype hierarchy, so does implementing. So I can store, I can come down here and store a dog in a named variable. Now what can I do with a named variable, with this N object? Can I call getName? We get back spot. Can I call speak? No. Okay, why can't I call speak? Because I see it right there. Yeah?
N doesn't inherit animals. Like that. It doesn't work the other way.
Yeah, there are lots of ways to put it, but the bottom line is I can only do the things that it says right here I can do, and that's get name. So I can't call speak. Now what if I happen to know that N contains a dog and I want to call speak on it? What do I have to do? I got to do the downcast. So I got to say, okay, I know, trust me, N is a dog. If I'm wrong, I'm going to get a runtime exception, but I'm right, so I get spot. Yeah?
Get name is not a dog.
Get name is not what?
It's not necessarily a dog.
Well,
Like you could do that with.
yeah, get name. get name is a dog method because I put it in there.
Right.
Mhm.
What I mean is that like you could do that before it was cast.
Yeah, before, if you just had a dog by itself, we could call get name. Sure. But once so when you take an object like a dog and store it in a variable of some interface type, it's not like those methods, those extra methods are stripped away and thrown away. It's just they become inaccessible. When a dog object is stored in a named variable, then you can only apply the methods that the named interface has. But if you take that same object out and cast it back to dog, it behaves like a dog again. It was a dog object all along. You just couldn't get at some of the methods. Yeah?
What if you put like a static variable in the animal class? Could like both of them, would all the dogs and cats be able to edit the same variable then?
So if we did this, if you went to the animal class and for whatever reason said protected static int n equals 7, then from the dog class, we could access you can access those static variables, sure. Kind of I'm not sure what the use case would be.
What if the dogs have to share food with the cats?
What's that?
What if the dogs have to share food with the cats?
Well, if the dogs have to share it with the cats, that won't work. Dogs and cats don't get along. All right, let's first of all, what's wrong with my main here? Oh, okay, let me show you my main method here. So I'm going to create Spot the dog and Fluffy the cat. Oh, cats don't have names. Forget that. And in this program they don't, and then we'll make it Rover. Okay. So I'm creating an array list that contains a dog, a cat, and a dog. Now, why is it we can put dog, cat, and dog in the same array list? Since they're different types. They're all animals. So we can make a list like that, and then we can iterate through the list, and I'm going to print out the result of calling speak. So when I run this, I get woof, meow, woof, because I've got dog, cat, dog. Okay? Now, what if I also wanted to print out the result of calling the fetch method? Why does that not work? Yeah?
Is it because cat is not an
Yeah. Well, it's because animals, again, the compiler is being very conservative. It says, okay, I don't know what A contains. Sometimes it may be a dog, sometimes it may be a cat, and that's completely true. All I know is it's some kind of animal, and animals don't have a fetch method. Only dogs. And so it's going to call that an error. Now, what if you wanted to call fetch if the animal happened to be a dog and not call it otherwise? How could you do that? What's the operator I use? How do you test that this animal is actually a dog? We test if A is actually an instance of dog, and if it is, then we can safely cast that A right there into a dog object. We're just saying, trust me, it's actually a dog object, and then we get that output. Woof true, meow, woof true. So it only calls the fetch method on the cast dog. Now if that looks confusing, you could break it out like this. You could say dog D equals dog A. You could do the cast, and then you could say d.fetch. It takes a few parentheses to actually put it into place like an expression. But okay? Last example, let's create a new kind of class. So I'm going to create a new class. I want to call it, what's this tiny kind of dog? That's too complicated to spell.
Spitz.
Terrier.
Okay. Okay, terrier. And we're going to make the superclass be dog. So let me finish this. All right, so I've got terrier extends dog, and now it's complaining because Well, it's saying I did not define the constructor. So what's that mean? So the error message says implicit superconstructor dog is undefined for default constructor. Must define an explicit constructor. What's going on here? Remember, here's a dog class. Yeah?
Dog's only constructor takes a string.
Okay.
The terrier class needs to know how to like make the dog, so you have to call it its constructor.
Okay. So to paraphrase what he said, since we did not provide a constructor for terrier, Java provides one for us. And this is the one it provides. Terrier. And this is... So what I have there is the default constructor that Java provides if you don't give one of your own. And the problem is the default constructor wants to call super with no parameters. That's got to be a constructor defined in the dog class. But there is no such constructor in the dog class. The constructor in the dog class takes a parameter. So how are we going to fix this? Okay, we've got to pass a string. You've got to pass the name of the dog here. So really, terriers have names too. So we'd better pass in a name to the terrier constructor, and we'll pass that along to the base class constructor so it can deal with the name. Now, terriers don't say woof. What do terriers say?
My terrier says wolf.
Well, okay. I wanted a small animal because terriers say yip, let's say. So if we want this kind of animal to speak differently than a dog, we'll just override the speak method and make it say yip. Okay. Otherwise, it's just like a dog. It just speaks differently. So we will go to, what happened to J-shell here? Right here. Let's reload. So let's say terrier T equals new terrier Bob. Okay? So what's going to happen when I say T.shout? Uppercase yep. Think about what happened. We don't have a shout method. That was inherited from the dog class, which inherited it from the abstract animal class. And the dog method that knows how to speak, we overrode it. So it says yip instead of woof. Now, can we store, A is an animal variable, can we store T in an animal variable? Sure, except there's no A declared. That's good. Can we do this? Can we store it in a dog variable? Yes. Can we do it the other way around? Can you take something in a dog variable and store it in a terrier variable? Compiler's going to complain. But we happen to know that there's a terrier in that variable. So we can tell the compiler, trust us, this is going to work out at runtime, and it does. So what I've been trying to show you is a whole bunch of stuff that have to do with what happens with these inheritance hierarchies, these implementation hierarchies, subtyping. There's a lot going on. Hopefully you'll get a handle on it before too long, because you'll need it in the asteroid class.